My name is Albert A. Michelson, and my project is on an experiment that tried to detect the luminiferous ether, which is also known as the ether wind. Me and my partner, Edward Morley, worked on this in the late 1800s, and in case you were wondering what the ether wind is, it is similar to water when it carries waves in a lake. So much like water carrying waves, there's theories proposed back in the day that in order for light to travel, it required a medium such as the water or the wind for sound for light waves to travel through. So this medium was thought to be called the ether. I worked with my associate Edward Morley on this experiment and built a device called the interferometer, and our experiment was the first of many that led to the ether theory being disproved. So there was what we were trying to do was the purpose of our experiment was to determine if there really was an ether that allowed for light waves to travel through. Much like other waves traveling through their specific mediums, up until this point, people believed there was an ether that allowed for the light waves to travel through, but that it was invisible to the human eye. So because of this, I built my interferometer to determine if there was any evidence of the ether being present. Our experiment became the basis for many more experiments that were far more complicated and that also helped disprove the theory that the ether wind existed. Our device, the interferometer, consisted of a laser beam, a movable mirror, a fixed mirror, a semi-transparent mirror, and a screen for detection. And so this could be run at any time of day, and the laser beam would cast a light, and the speed of light in two different directions would be measured. And so these two measurements of the speed of light were compared. And since these measurements showed that there was no difference in the speed of light, it established a basis that proves there is not a substance or ether that the light waves travel through. It was also done at different times of day to account for the Earth spinning around the sun, and there was not any difference in the speed of light measured for the in two different directions then. So this helped prove that there is not a substance known as the ether that light waves travel through. This was really surprising to the physics communities at this time in the late 1800s. Overall, our experiment was really important. So our experiment occurred in the late 1800s. I did some preliminary measurements with a simple apparatus in 1881 in Germany. It wasn't until 1887 that I met up with Edward Morley to do our famous experiments, which have become known as the Michelson Morley Experiments. Our 1887 experiments were performed at the Case Western Reserve University in Cleveland, Ohio. These were the ones that helped disprove the ether was a substance. Later, many more people did more complicated experiments that further disproved the ether theory. So during 1887, there were many events that happened at the time that were significant around the world. One of these events was Gustave Eiffel, an architect in France, began his work on the Eiffel Tower in Paris. A treaty called the Reinsurance Treaty was signed between Germany and Russia. Now that you probably know about this guy, Sir Arthur Conan Doyle published Study in Scarlet, which is the first book that Sherlock Holmes appears in. The first Groundhog Day was observed in Punxsutawney, Pennsylvania, in the U.S. of A. One of the more tragic events that occurred was the French Italian Riviera earthquake that killed over 2,000 people. So overall, lots of significant events occurred, but I believe Morley and I's experiment was the most significant in 1887. For my project, or for our project, it was just mostly me and Edward Morley who helped complete this experiment, and because of that, the experiment is named after both of us. My major role in this project consisted of constructing the apparatus and helping to collect data on it. I created the first prototype in 1881, but it was not until 1887 that I got with Morley, where I was able to refine the interferometer and we obtained our results that disproved the ether wind. These experiments were my idea in 1881 in the first place, though. So the impact of this experiment was huge on the physics community. First of all, our experiments were the first of many that disproved that there was a ether. Then also it led to the branch of physics that deals with relativity. So not long after ours experiments were published, a guy named Lorentz tried to attribute our negative results of the ether by constructing the length contraction equation, which this led to many more equations being developed by Poincare, Lorentz, and others, and then it also led to Einstein coming up with his theories of relativity. Overall, this experiment was really important for the physics community. So yes, I was a part of many societies. Just to name a few, I was a part of the American Physical Society, the American Association of the Advancement of Science, Royal Astronomical Society, the Royal Society of London, and the Optical Society. Thank you so much for having me today and letting me talk about my Michelson and Morley experiment.